Let's take a look at the examples from chapter 8, starting with true or false questions. Sampling error is the difference between a sample statistic and a population parameter. This is exactly what we talked about in the notes. This is true. To use the central limit theorem, we need to know the mean and standard deviation of the population. That is false. We need to know the sample size, or we need to know what distribution the population follows. As the sample size increases, the interval that contains 95% of the sample means becomes narrower. That's correct. That is true. A what sample is a sample in which every member of the population has an equal chance of being chosen. This would be a simple random sample. In what sampling we divide the population into mutually exclusive groups and randomly sample from each of these groups. That would be the stratified. We divide the populations into stratas, as we call them. The central limit theorem states that the sample means of large size samples will be normally distributed regardless of the shape of the population distribution. That is the correct answer. Clearbugs is an online company that sells packaging materials for photographers. Suppose their average order size is 208.19. The standard deviation is 53.44. A random sample of 35 customer orders has been selected. The standard error of the mean for this sample is the following. Now, all I'm asking is sigma x bar, the standard error. Sigma x bar is equal to sigma over square root of n. Sigma is equal to 53.44. Sample size is equal to 35. So 53.44 over the square root of 35. This will give us $9.03 for the standard error of the mean. An Epson inkjet printer advertises that the blank ink cartridge will provide enough ink for an average of 245 pages. Assume that this claim is accurate and that the standard deviation for the population is 15 pages. A random sample of 33 customers was surveyed about the number of pages they were able to print with their blank ink cartridges. What is the probability that the sample mean will be 246 pages or less? So I'm looking for the probability of x bar to be less than or equal to 246. We have mu equal to 245. We have sigma equal to 15. We have n equal to 33. We graph the normal distribution. Mu x bar is equal to mu equal to 245. 246 is to the right, and I'm looking for the area where x bar is less than or equal. That means the whole area to the left. Z-score will be 246 minus 245 over 15 divided by square root of 33. Please make sure you use your parentheses when you do your calculations. This is going to be equal to 0.383. You round up to 2 decimals, so you look up your table for 0.38. 0.38 will give you a probability of 0.148. This part of the area is 0.5. 0.5 plus 0.148. This will be, therefore, the correct answer, 0.6480. Suppose the average driving distance for last year's Master Golf Tournament was 282.5. So mu is equal to 282.5. Standard deviation 12.2. A random sample n of 30 drives was selected from a total of 4,144 drives. What is the probability that the sample average was 279 yards or less? So I'm looking for the probability of x bar to be less than or equal to 279. We draw the normal curve. Mu x bar is 282.5, same as the population mean. 279 to the left, less than 279, I'm looking for a left tail. Next step, as always, we calculate the z-score. 282.5 minus it's 279, the other way. It's 279 minus 282.5 over 12.2 divided by square root of 30. Again, use your parentheses. If we calculate the z-score, this is going to be negative 1.57. We take the absolute value, that means 1.57. We check our table. This will give us 0.4418, and since I'm looking for a tail, 0.5 minus 0.4418. Therefore, the correct answer in this case will be D. Now, let's look at the problems. According to the National Retail Federation, men spend an average of $484 over a recent Black Friday weekend. Assume that the standard deviation for this population is $146. A random sample of 42 men shoppers over this weekend was selected. What is the probability that the average amount spent on Black Friday weekend from this sample was less than $500? So this is the probability that I am looking for x bar to be less than 50. You draw your normal curve, mu x bar for 84. We have 500 for our value. We want less than this value, so it's the whole area to the left. The z-score for 500 will be 500 minus 484 over 146 divided by 42. 0.7102. Again, you round up to decimals. You look up 0.71. 0.71 will give you a probability of 0.2611. This is 0.5. All you need to do is add the two probabilities. So 0.2611 plus 0.5, 0.7611 for the area, for the probability that I'm looking for. In the second problem, according to the National Retail Federation, women spent an average of 317 over a recent Black Friday weekend. Assume that the standard deviation for this population is 90. A random sample of 50 women shoppers over this weekend was selected. What is the probability that the average amount spent on Black Friday weekend from this sample was more than 300? So the mean is 317. Sigma is 90, N is 50, and this is the probability that we want. You do your graph, you graph your normal distribution, mu x bar 317, 300 to the left, greater than 300, I'm looking for the whole area to the right of 300. So, z-score, 300 minus mu in this case is 317, over sigma 90 divided by square root of 50. So this is equal to negative 1.336. Now, we round up to 4 decimals, to 2 decimals, so this is going to be negative 1.34. This is what you will check your table for. 1.34 will give you a probability of 4099, which is the area from 0 to negative 1.34 for your z-score, or 300 to 317. This area we already know is 0.5, so therefore 0.5 plus 0.4099, this is equal to 0.9099. Now, for problem 3, according to Nielsen, the average smartphone owned used 606 megabytes of data per month. Assume that the standard deviation of data usage was 240 megabytes per month. A random sample of 60 smartphone users was selected. What is the probability that the average amount of data used in this sample was less than 580 megabytes? So, the mean is 606, the standard deviation is 240, the sample size is 60. We calculate the probability of X bar to be less than 580. We graph the normal distribution. This is the area that I'm looking for. I'm looking for a left tail. We calculate the z-score. The z-score will be 580 minus 606 over 240 divided by square root of 60, and this will be equal to negative 0.839. Negative 0.39. We will round up to 2 decimals, so we're going to look up negative 0.84. We take the absolute value of that. 0.84 will give me a probability of 0.2995, and therefore, since I'm looking for a tail, we will do 0.5 minus 0.2995. So this will be equal to 0.2005. So this will be the answer. So this concludes the examples for chapter 8.